Alright, internet. So I went to Harbor Freight Tools a few days ago and I got this pickup and reach tool. As you can see, it is just a grabber thingy. It's basically a claw and it's springed. So whenever I press this down, it closes, and if I leave it open, it opens. What I'm going to do today is I'm going to turn it into a robotic claw using the linear actuators of the car door lock motors. You see these things right here. So the idea is that I'm going to have it so when this goes down, it closes and then it just brings it back up. Something like this. There is a cable going through this tube, and that cable is going to go through here, and then I'm going to mount both of these on a surface, and when that goes down, I'll do that, and we'll have a robotic claw. I'll probably put this on my humanoid robot, maybe. Right now it doesn't really have any kind of claws on it, just kind of has palms of the hands. So we can have this, and it can have a pretty good robotic claw. To start this off, we have to take apart the handle so we can get the claw loose. So I took it out now, and we should be able to just take this off. So we were able to take it off, and basically we just have this cable, and it is a steel cable, so we can just pull it down and we can have our claw going like that. There is a limit on the travel of this thing. It can go about an inch of travel. This might be about the same, but there is the possibility where we would not be able to fully close it using this, so we'd have to adjust this position so it would just be closer together, and then it would do that. But I think we should get a good travel out of this, and you're never really going to grab something this big anyway. You probably couldn't with this type of claw. It just wouldn't have the grip. It only has little rubber grips on the low ends and then some spikes. So to lay out how we're going to do this, I think the best idea would just be to snake the wire through this tube, tie it around, and then get some of this. This is some aluminum. It's just some sheet of aluminum, and I got a little piece of scrap metal. This is why you save your scrap metal. And I think I'm just going to bend it around and then crimp it on there, and that should work to hold it in place. If not, we can just find some other solution. But let's look at the mounting hardware that came with the actuator. Okay, so the actuator came with a push rod. I don't think this is going to be of much use at all. It also came with this bracket. I think it's a mounting bracket that you can screw it on to the edges, and we might be able to rig this to some sort of a solution. As for mounting the gripper, what I'm going to do is I'm going to cut this tubing, and then we are going to insert this into a 3/8 inch hole of a pipe or something like that, and then we'll have this just extending down. Okay, so what I have here is our arm. You can see what I did is I got a little piece of aluminum and crimped it on to this wire. So it is going through the hole of this linear actuator, and when I do that, closes. It's not really hooked up now because this still has to be pushed back all the way, and that's what we're going to do. You can see that this is a PVC pipe I drilled out, so I could cut off a little piece of this bar, and I just cut it off, shoved it in the tube, and the tube braces itself against the plastic, and I have two 3/8 inch bolts going through. I am probably going to put washers on these, but it's not really necessary right now. And for the end of this, I'm going to have another one of these PVC pipes. It's going to go through here, and probably through one of these holes there's going to be whatever secures the two things. Maybe it could be this push rod, for example. It could go back, or I don't know. Maybe even I could use some of this extra cable that came with the grabber thing. So let's get to work doing that. Of course, all we need to know is that we do another one of these things, basically. You can see that the lengths of these are approximate, but it's roughly 3 inches across, and there's a whole half an inch here, half an inch here, and one in the center. So let's do the same thing and mark it out. Now we can just drill out all these holes. For this one, it was that one of the holes was half an inch so the pipe could go through, but we don't need to do that here since we're just going to be running cables through it, and everything's going to be drilled at a smaller size. Okay, so here's our finished arm. This would probably not be the one that I would put on the robot just because of the steel is pretty heavy, but if you just needed a robot arm for some reason to put it on something, you could easily mount it on some other area to the screw bar, maybe so the joint could be like here. I might actually do that. I don't know, but basically how it works is that I did the thing with the string again, the metal rope thing, is that it's crimped on at this end and it's also crimped on at this end, so the actuator is suspended in between these two pieces of pipe, and when it goes down the arm closes. There's a lot of force involved here, but let's just hook it up and watch it go. It is powered by 12 volts, so you are getting that, which is easy to power it. The green wire is positive and this is the negative wire. you just need to wire it up this way because the spring tension of the hand thing, it just pops it back in place. So let's turn it on, and as you can see right there, it did move. So I'm not even using an H-bridge or anything to make it go back. It just does that automatically with spring tension. Let's try to grab something. So here's a piece of pipe. Let's try to grab it. Yep. Let's try to grab this box. It's a pretty heavy box. We can't get a grip on it though. So let's see if we do get a grip on it. Yeah. It challenges with those, but let's try something small like this piece of metal here. Okay, I can grab that. How about this bag back here? Yeah, perfectly fine. Let's try a piece of this. You can see that there's some more string here. It even grabs that. Try it again. Okay, we're not professionally doing this right now. Yep, grabs it. And it can hold down. So as you can see, this is, I guess it's a decent idea if you needed a robotic arm or a prosthetic arm for some reason. I would do this. Obviously this needs more refining before I can put it on my humanoid robot, but I'm sure this is good enough for a lot of applications. But as you can see, this is crooked, kind of. Maybe we could use some epoxy here, and this plastic is kind of weak, it's bending. Maybe I would use some aluminum. I would probably have this entire frame be aluminum, just so it's less heavy and it's less weak on these ends. It's more compact as far as these go. I am kind of worried that the wire will slip out. Maybe I'll get some better crimp connectors or tie off the wire in a different way. Obviously what is good about this screw connector is that you can move this back and forth, adjusting it. So let's say instead of you want it starting off here to be there. So if you do that, you can have more force pushing on it. Or also you would probably want some force sensors around here. Just some basic ones. This isn't a real prosthetic hand, but you would need something basic just so this motor can stop when it's grabbed something. As this way it is that the motor does get kind of hot when you do that. These are car door locking motors, so I don't know exactly how long their duty cycle is, but it's clearly not meant for this type of application. It just kind of locks the door of the car and whatever happens. But it does appear to work at least good enough for this. So there was how to build a robotic arm out of whatever, very basic materials. I'd say around $15 you could do this. This was cheaper actually because this is like $5, this is $2, and this is just whatever, so maybe like $7 if you spend your money wisely. Let me know what you have to think about this in the comments. Obviously just make it smaller, and that would be a better solution.